pipeline to get required output. Here, stream contains objects to process. So write it. Here, stream is a collection of objects Here, stream is a collection of objects that are pipelined to process to get desired output, desired result. Here, stream is a collection of objects that are pipelined to process to get desired result. Here, stream is a collection of objects that are pipelined to process to get desired result. So, objects you can pass to stream. On that, many methods are there. You can process. At last, required output comes. That is. Stream API contains several useful methods Stream API contains several useful methods that are used to perform operations on objects. Stream API contains several useful methods that are used to perform operations on objects. Here, one interface is there, stream. That is in stream package only. See, Java P java.util.stream.stream. This is stream API. See how to perform, what we can do, I'll explain. Many methods are there, but required very regular, whatever we use, that is I'll give. Methods. Just you write like a T better without confusion. It is used to filter the data based on predicate logic. It is used to filter the data based on predicate logic. This T you can remove, but better understanding. If you write also, nothing will happen. This just understanding purpose, I'm giving like this. Then easily you can understand. That's what I'm giving. It is used to map elements based on function logic. It is used to remove duplicate elements. It is used to sort the elements. It is used to iterate based on consumer logic. It is used to convert an array. It is used to perform reduction operation based on binary operator logic. It is used to collect elements. There are so many methods will be there. Leave it. Right is all more than enough. Right is all. So you can filter the data based on predicate. Predicate already studied. You can map based on function. Distinct, sorted, these all by default works. But again, for each consumer required. Predefined function interface is required again. Lambda expression, predefined function interface. With that, we can write. So these all methods in stream interface. Stream interface, abstract methods, but no need to implement, already implemented in collections. Just elements we can pass to stream, then we can perform these operations. Is it completed? Say filter, we can filter the elements. In a stream, hundreds of elements will be there. Whatever you want, according to your logic, you can filter. Map, each element you can map to another element. Distinct, you can remove duplicates. Nothing but only unique element comes. Sorted, it is sorted for each, iterating. It's like an answer for loop type. To array, converting into array. Reduce, reduction operation, like a finding maximum, finding minimum, at last one value comes. Collect, all you can collect like another object. These all we can perform. You observe. Suppose one array list. Array list integer al equal to new array list. Al dot add. Al dot add. Al dot add. Al dot add. That is numbers. System dot out dot println al. Now import java dot util dot star. Okay. This program you already studied. Here just output my order comes. Now these elements my order as it is printed. Now if you want to iterate these elements, which interface we use? Iterator. We can also use enhanced for loop. Okay, you can also use enhanced for loop. You can also use list iterator. You can also use enumeration legacy collection. So if you want to iterate these elements, iterator is there, list iterator is there, enumeration is there, enhanced for loop is there. But now with lambda expression also we can iterate. How? Here for each method. Now this method, if you want to call this method in which interface? Stream. First of all, we record stream reference. Further, in a array list class, you can search method is there or not. You observe. Array list class return type should be stream. So it is not there. If not there, where you have to search? Abstract list. Okay. Abstract list, interfaces, and at last year super interface is there. Abstract list you can search. In our list, not there. Abstract list. Say here abstract list. You can search for stream. Here also not there. Then which is superclass again? Abstract collection. Java p java dot util dot abstract collection. Here stream. Here also not there. Implements collection. Okay, implements collection. In the collection interface, somewhere implemented, that is. Otherwise, it will not work. Stream. You observe. Here we got it. Stream method. So it is default method. It is interface only, but this interface contains default method. Nothing but concrete method. No. If you call this method, you will get a stream. With that, we can call. It is super interface for all interface collection. Here method. This method required to get a stream. Not done. It is used to pass elements of a collection to a stream. It is used to pass elements of a collection to a stream. It is used to pass elements of a collection to a stream. It is used to pass elements of a collection to a stream. So first elements you have to pass to stream. Then you can perform operations. So in this method only implemented. So it is not abstract method. That's what here only concrete method. It is used to pass elements of a collection to a stream. Is it over? This method, if we call, you'll get a stream. No. What is the return type? Stream. Which type? Integer. EL dot stream. Can I call? Yes. Here array list like this. 1, 2, 3, 4, 5, 6. These elements 84, 45, 78, 75, 81, 89. This is array list. This array list object. It is called collection. Okay. Now, whenever this method is called, what will happen? One stream created. EL dot stream. These elements one by one pass to stream. It is stream. So stream means flow of data. Now your collection of objects. These all data. It is passed to stream. But here, what we can do in this, it is stream. Now elements are in stream, inside stream. Now you can perform some operations here to get the output. So what I'm doing, I'm sending 6 elements, but whatever you require, that operation you can perform in that stream only. All elements are pipelined, but you are going to get required output only. All you are not going to get. Suppose you want to iterate, then all comes. Suppose you want to filter only even numbers only comes. If you want to map each element to another element, that particular element comes. If you want to sort, getting sorted ascending order comes. If you want to count, all elements counted. If you want to remove duplicate, unique elements only comes. Like that. What we are doing is, this collection of objects we are passing to stream. Then required output you are getting. But already so many methods are there. Why this stream? Okay. You can reduce the number of lines because the lambda expression, predefined function interface, no? That purpose. Now, I want to iterate. How to iterate? Which method required to iterate? Here, just now, for each. Method name only for each. This method we have to call. For each method. For each method, what is the parameter? Consumer. You already studied consumer, no? What we have tried for consumer? Consumer integer C equal to lambda. Lambda we have tried, no? What we have tried? A arrow system dot out dot println A. This is consumer logic. You already studied last class. Okay. So consumer C equal to A. This is. Now for each method in which interface? Stream. Already we have stream reference. For each method parameter is consumer is there. We can pass no. Now what you have tried? S dot stream. S dot for each of C over. It is iterated. You observe. File. Save. Compilation. Execution. Now consumer class in which package? Consumer class in which package? Function package. Stream interface in which package? Stream package. These are sub packages not included in this star. What is the meaning of star? All classes, all interfaces, but function, stream, sub package not included. Explicitly outright. See file, save. Now that is the reason error came. 2 errors. One is consumer purpose, one is stream purpose. See. Iterated. No? All elements are one by one iterated. Now, while iterating +5 if you want, here +5 you can write no. 5 marks, bonus marks, like that added. Iterated. No? Now here you observe, here, these 2 lines, can I write as a 1 line? What we have tried? Consumer. No, what you write? Not consumer. Here, what you write? S dot for each. Here, A arrow system dot out dot println a plus 5. This is functional programming. See what I passed? Logic only I passed as a parameter. Now here what I passed? Consumer reference I passed. Here consumer logic only I passed. Complete logic as a parameter. Okay. Now, so these two lines I written like this. Now, 3 lines I want to write as a 1 line. Possible or not possible? Possible. Then what you have to write here? AL dot stream dot for each of a arrow system dot out dot println a plus 5. Like this also valid. So these 2 lines I written like a 1 line. This line I written like a 1 line. Okay. Write this one. Program to demonstrate for each method. Program to demonstrate for each method. Three lines like a 2 lines, 2 lines like a 1 line. So these three we written like a 2 lines. These two we written like a 1 line. See, at the time, iterator, list iterator, enumeration for each loop you have studied, but just here 1 line, 1 line code. Iterated, added, printed, everything done in a 1 line. So we can concise the code. So there minimum 5 lines were written. Here just 1 line. The 1 line only is printed. Is it over? Now, first year what will happen? See, up to here already you studied. Up to here already studied. Array list reference dot stream. Array list reference dot stream method if we call, all elements are passed to stream. Nothing but flow of data. Here, this is on stream. Whenever this method is called, 6 elements are passed here. Stream received. The stream elements only iterated 1 by 1. So 1 by 1 iterated plus 5 added printed. Suppose here 6 elements are there. Now I want to filter. Now only even numbers I want to print, or only odd numbers I want to print, or those who got marks 70 and above marks I want to print, or those who failed less than 40 I want to print. This type of operations are filtering. Only those who got distinction, those data I want to print. Those who got first class, that data. Those who failed, that data. Those who got second class, that information you can filter. How to filter? See, again, first of all, it is common. Up to here common. Up to here common. Now, first you have to pass the elements to a stream. How to pass? Stream integer s equal to al dot stream over. Now elements are passed to stream. Now these all elements are present in a stream. Now you can perform operations. Suppose I want to filter. If you want to filter method, if you want to call, predicate logic required. Okay, predicate you studied, no? Predicate logic you have to write. What we have to write? Predicate integer p equal to lambda you have to write. Now I want to filter even numbers. What we have to write? A arrow a modulo division 2 double equal to 0. That is predicate logic. Okay, predicate always returns true or false only. You studied. It is predicate logic. Now this predicate logic you can pass to filter, but here one more return type, stream only again. What you have to write? Stream integer s2. Suppose it is s1. Okay, it is s1. Here s2 equal to s1 dot, what is the method name? Filter. Filter. What we have to write? P. Now filter method parameter is predicate. Return type stream. Stream s2 equal to s1 dot filter p. Okay. Now this stream data, if you want to print, again for each requirement, what you have to write? s2 dot for each. What it takes? Consumer. What we have to write? Consumer integer c equal to a arrow system dot out dot println a. Here for each what you have to write? C over. Here in this line elements are passed to stream. It is predicate logic. With predicate logic filtered, another stream created. This stream contains only even numbers. This stream contains all numbers. All numbers. Here only even. Even numbers are iterated. See, file, save. Now, from this, how many even numbers? Only 2. 84, 78. Okay. Now you observe this last two lines. Can I write as a one line? What we have to write? Give me answer. S2 dot for each. Here A arrow system dot out dot println A. You can write. Okay. These last two lines we written like this. These two lines can I write as a one line? Yes or no? Then what you have to write? Here what you have to write? Now these two lines I written as a one line. Now these two lines I want to write as a one line. Now what we have to write? Stream integer s2 equal to s1 dot filter a arrow a modulo division to double equal to 0. Okay. Now you observe these two lines I written like a one line. These two lines I written like a one line. These two lines can I write as a one line? Can I write? Yes or no? What you have to write? Here what you can do is just give me answer. S1 dot filter a arrow a modulo division to double equal to 0 dot for each of a arrow system dot out dot println A. Okay. Now here S1. S1 place what is there? That is also can write no. AL dot. AL dot stream dot. AL dot stream. You observe here 1, 2, 3, 4, 5. These 5 lines, one line. Actually, these 5 lines also many lines of code is there. Okay. Each year predicate logic actually even numbers if you want to print. You have to write each element, you have to pass, then you have to call. But that is 5 to 10 lines. Here 5 to 10 lines. Almost 20 lines code just in one line. You observe. Now I'll make it this one comment. Up to here I'll make it comment. This is inside the main. This is class close. I'll run this program. You observe. First, collection elements passed to stream. With that filtered. With that another stream created, printed. File, save. Now same output comes. You observe. See, just one line. Just one line. So almost 20 lines code, that is. You try to write that program to filter and display iterate 20 lines code required. The 20 lines just in a one line we can write. That is the power of Stream API. We can concise the code. We can reduce the number of lines of code. So this much code we written like a one line. Now here understanding purpose, what you do is 1, 2, 3, 4, 5, first 5 lines. After this, this first stream also I'll write again. Stream integer s1 equal to al dot stream. Actually, here 1, 2, 3, 4, 5. 5 lines we written like a 3 lines. 3 lines we written like a 1 line. Okay. 5 lines like a 3 lines, 3 lines like a 1 line written. This 5 lines code, 3 lines. Now these 3 lines code, 1 line. Ready? So now program to demonstrate filter method. Five lines code, 3 lines are given, 3 lines code, again 1 line are given. So these 5 lines we written like a 3 lines. 3 lines we written like a 1 line. Is it over? I'll explain once again, just you observe. Here, first what will happen, see, array list reference dot stream. Then all elements pass to stream. Here, predicate logic. Predicate logic, we are filtering only even numbers. That's what even number logic are written. Here, in that S1 nothing but all elements are there. S1 dot filter P. P nothing but even number logic. Okay. Here, even number logic applied, filtered. Now S2 contains only even numbers. That S2 even numbers printed with this consumer iterated. Just you observe here, in the place of C, can I write this one? Okay. So here S2 dot for each of C place, this part you can write. This is I'll cut. Here I'll paste. Then this line is not required. Okay. Here P place this logic. I'll cut. Here I'll paste. This is I'll remove now, not required. Now here you observe S2. S2 means this is. This is I'll cut. Here I'll paste. This is not required now. Here S1. S1 nothing but this is AL dot stream. I'll cut. Here I'll paste. Then this line not required. So even in lambda expression streams also 5 lines code are written like a 1 line. Okay. File, save, compilation, execution, filter. Now if you want to filter odd numbers, what you write? Here not equal to 0, odd numbers. Now I want to display only those who got marks greater than and 70. Then what you write? A arrow A greater than 70. Even numbers you can filter, odd numbers you can filter, greater than 70, less than 40, first class, second class, whatever you want you can write. Okay. Suppose only 60 to 70. A greater than or equal to 60 and less than 70. That is you can write. You can filter whatever you want, but filter method is there, logic you apply, that's it. Like that you can filter. This is a concept. Mapping. Suppose 84 you can map to 89. So 45 you can map to 50. Like that you can map. Each element you can map. Filter, what will happen? Same number of elements comes or less comes. But mapping, all elements comes. But you're adding or you're removing, you're subtracting, you're multiplying, that type of operation. See what you can do here. Map method if you want to call. It is function. So first normal stream compulsory. Stream integer S1 equal to AL dot stream. It is compulsory. Now map method if you want to call function required. function, integer, parameter also integer. Now return type integer, parameter integer, f equal to. Function logic you studied, no? What you have to write? A arrow, a, suppose here if elements are cube, calculating cube possible. If you want to add 5 bonus marks, a plus 5. Next, map method you have to call, return type is stream. Stream integer s2 equal to s1 dot map f. If you want to print, consumer logic required again. Consumer integer c equal to a arrow system dot out dot println a. If you want s2 dot for each c over. Now file, save. See 89, 50, 83, 80, 86, 94. Now again 5 line, 3 line, 4 lines. I'd like directly 1 line, give me answer. Okay, again 4 line, 3 lines like that, not record, directly 1 line. Only 1 line. AL dot stream dot AL dot stream dot map a arrow a plus 5 dot for each of a arrow system dot out dot println a. Understood? No, that's it. Okay. This is map. Not a program to demonstrate map method. Now you can find out square also, power also, cube also, any mapping. Each element mapped to another element. So here in this line, elements are passed to stream. Here function logic, based on that function logic mapped, those elements are passed to second stream with consumer logic iterated, printed, but all in a one line. Okay. Now, is it completed? Now, I want to sort these elements with this stream API. Which method you have to call? Sorted. First, you have to pass the element to stream. What do you have to write? Stream integer s1 equal to al dot stream. Next, return type. What is it? Return type stream. Then what do you have to write? Stream integer s2 equal to s1 dot sorted. Next, if you want to print s2 dot for each, here consumer a arrow system dot out dot println a. Now these two can I write as a one line? Yes. What you have to write? S2 plus s1 dot sorted. Okay. Now this line not required. S1 plus al dot stream. That's it. File save. See. Okay, sorted. If you want to display, if you want to remove duplicates, same one line, give me answer. Al dot stream dot distinct dot for each a arrow system dot out dot println a. Now only distinct element printed. Here system dot out dot println before sorting. Here system dot out dot println after sorting. Okay. Here system dot up after removing duplicates. You observe first before sorting, like this printed. But like this again, if you want to display like this, you have to collect element as a list. Collect method is there. It is after sorting. It is before sorting like this printed. After sorting, see sorted. Here duplicates removed. You observe. Here how many element total? 6. Duplicates are not there. 1 minute. Suppose it is also 45. I'll write. It is 84. I'll write. Now you observe file save. Duplicates are not there. That is the reason like that came. See, duplicates removed. Now 4 element, 2 duplicates are there. It is before sorting. It is after sorting. Here after removing duplicates. Write this one. Program to demonstrate sorted and distinct methods. Here directly one line only given. So here elements are passed to stream, sorted, again another string created with that iterated, printed. Here elements are passed to stream, duplicates removed, to another stream, printed. Okay. We'll see continuation tomorrow. Just in 3-4 days, it will finish.